Hi everyone, today I'm going to walk you through Lab 2's activity worksheet. To begin, we should notice that this note here that says all numbers are 2 nibbles. This means that since 1 nibble is 4 bits, we should be expressing and calculating our answer with 8 bits. This will be important later on, especially as we work with 2's complement and we're inverting our numbers. We want to make sure we're inverting all 8 bits, not just some of the 6 or 7 given bits. Question 1, we are given decimal 89. This means we should first try to convert it to binary, and then it'll be really easy afterward to convert that binary to hex. So with converting decimal to binary, we want to divide by 2 and use the remainders to continue dividing until our divisor is equivalent to 0. Great, so we finished dividing. Now when we build our binary number, we know that their most significant bit, which is the bit in front, is going to be on the bottom, and then our least significant bit is going to be in the back. So we'll write it like this: 1 0 1 1 0 0 1. And notice that we only have 7 bits here, so we're going to fill in that first bit with a 0 because we do want this to be in 8 bits. And I'll color this. So this is our number in binary. All right, let's use this number to calculate the hex number. We'll group our bits in groups of 4, starting from left to right, and then calculate each hexadecimal number. We know that 0101 is equivalent to 5, and then 1001 is equivalent to 9. And that's it for question 1. Let's move on to row 2. Row 2 gives us the hex number D0. Let's convert this to binary. We know that 0xD0 is equivalent to 0B1101 and then 0000. I'll be converting it from the hexadecimal number just because it's simpler this way. We can convert it when we understand that our places. So we know that this is the ones place and then this is 0. So this D, which is equal to 13 in the decimal system, would become 13 times 16 to the 1 plus 0 times 16 to the 0. And we're getting these numbers from the places over here. And then it would be 2, 3, 3, and so on. So this would be equivalent to 13 times 16 plus 0, which I believe should be 208. And we'll write that in our final answer for the decimal equivalent. Now in the second row, we have to add the hex value of row 1 and then add the hex value of row 2 and place that in this section over here. So let's calculate that. Plus 0xd0. 9 plus 0 is 9. 5 plus d is equivalent to 5 plus 13, which is also equivalent to 18. Okay, so we have this 18 over here. The main problem is the largest number that we can express in one column is going to be 15, which is equal to f. So we'll carry the 16. We're in base 16 in hexadecimal. That 16, we're going to carry it out to the next column, and we're going to express it as 1. But then we have this leftover 2 over here, right? So that means that 2 is going to be placed down here. And then since we're in the 8-bit system, we can only express 2 hexadecimal digits. So we don't actually have to worry about this carry out bit over here. We're just going to have our final answer as 0x29. Let's move on to the third problem. The third problem, we're given the binary, but now we need to figure out the hex and the decimal value. So we're only given 6 bits, so let's pad with 2 zeros in the front, so we have 8 bits. Converting this to hex is fairly simple. We have 0, 0, 1, 0. That will be equivalent to 2. And then we have 0, 1, 1, 0, and that will be equivalent to 6. So our hexadecimal value is 0x26. Now we can convert this to decimal. I'm going to use the same method I used before. Again, this corresponds to what place we are over here. So this is 1, and then this is 0. And that final value will be 38. Then for our add hex column, we have to add the sum, or add the hex value of 2 and 3. So that will be 0 plus 6 is 6. D plus 2 is 13 plus 2, which is 15, which is F. Now let's subtract the binary of row 2 from and row 1. We'll start out with 1 minus 0, which is just 1, 0, 0, 1. 1 minus 1 is 0, 0 minus 0 is 0, 1 minus 1 is 0. Then we have this 0 minus 1 over here. 0 minus 1 in binary subtraction, we have this invisible 1 over here that we carry over over here. And that 2 minus 1 becomes a 1. So then your final answer should be 1, 0, 0, 0, 1, 0, 0, 1. This is more like a special rule in binary subtraction. We're in the sign system now for these last two questions. Notice that we're given the decimal number -40. So we know that we're going to have to use 2's complement. So we're given -40. Let's convert it to binary. So make sure you keep track of this negative sign. So -40, let's convert it to binary. We're going to pad with zeros in the front. Then our first step in 2's complement is flip bits and then add 1. This becomes, and then we add 1. 1 plus 1 is 0. So that will be our final answer for the binary. Let's convert that to hex. 1101 in hex is D, and then 1000 is 8. Okay, let's add the hex values now. This time we're doing rows 1 plus 4 plus 8 equal to 17. This is greater than 15, so this means we have to do some carry. 17 is equal to 16. The amount will be carrying over, plus 1, and this is our remainder. So that remainder goes down here. We'll carry the 1 up there. 1 plus 5 is equal to 6. 6 plus D is equal to 6 plus 14. 13, which is equal to 19. That's greater than 16. 19 is equal to 16 plus 3. So that 3 is going to go down here, and then we have to carry that 1 up here. But remember, we're in the 8. We only want to express our answers in 8 bits, so we don't really care about this carry out anymore. So our final answer for the hex addition will be 0x31. Now let's do our binary subtraction. We'll do rows 4 minus 1. Alright, we're going to do a bit of borrowing over here. We have a 0 minus 1, so we'll need to borrow from this one over here. So this one becomes a 0, then we have a 2, need to borrow from that, becomes a 1. Then we have a 2 minus 1 is 1, 1 minus 0 is 1, 1 minus 0 is 1, 0 minus 1, we need to borrow. This becomes a 2, minus 1 is 1, 0 minus 1. Need to borrow from here, this becomes a 0, this becomes 2, 1, 2, minus 1 is 1, 1 minus 0 is 1, 0 minus 1, we need to borrow, this becomes 0, and then we have a 2 over here, 2 minus 1 is 1, we have a 0, minus 0, which is just 0. In question 5, we're given decimal number -114. Alright, we already know what to do. Let's convert it to binary. There's going to be 1, 1, 1, 0, 0, 1, 0. Let's pad in the front. Remember, we're in the sign system. We've got a negative number over here. So let's flip the bits and then add 1. Final answer is going to be 1, 0, 0, 0, 1, 1, 1, 0. Hexadecimal will become, this is an 8, the first 4 bits are an 8, and then the last 4 bits are an E, so 8E. Let's add the hex values of 3 and 5. Six plus E is equal to 6 plus 14, which is 20. That's greater than 16. So we'll do 20 is equal to 16 plus 4. That 16 is getting carried over. That 4 goes down here in the remainder. 16 goes up here as 1. 1 plus 2 is 3. 3 plus 8 is 11, which is B in hexadecimal. Finally, let's do some binary subtraction from row 5 minus row 4. We have to do some borrowing. Let's borrow from here. That will become 0. Then we have a 2 over here. That becomes 1. 1 minus 1 is 0. We have another 0 minus 1. We have this extra 1 that we can borrow over here, which is technically a 2 that we bring over here, and we do that 2 minus 1, which becomes 1. Alright, and our worksheet is complete. Yeah, this is really important for you guys to learn, and I hope this video was helpful. Thank you for watching.